Today we're going to focus on a few circle theorems and definitions, those sorts of things, things that we know about circles, the angles, and the lines involved with circles. For starters, we'll take a look at central and inscribed angles. We've learned already that the measure of a central angle is equal to the measure of the arc that it intercepts. Therefore, when I look at circle I here, and I'm given that the measure of arc KJ is here, is equal to 108 degrees, I can then conclude that the measure of angle KIJ, because it is a central angle, its vertex is at the center, is also equal to 108 degrees. Let's go ahead and fill that in. We also know that the measure of an inscribed angle, so an angle whose vertex is on the circle, is equal to half the measure of the arc that it intercepts. Therefore, the measure of angle KLJ is equal to half the measure of arc KJ. The measure of angle KLJ is equal to half the measure of the arc that it intersects. So then the measure of angle KLJ is equal to half of that 108 degrees. We divide both sides, or not divide, we divide that 108 by 2 or multiply by 1/2, and the measure of KLJ is equal to 54 degrees. Again, the measure of a central angle is equal. Remember, central, same, central, same. The inscribed angle, the angle whose vertex is on the circle, is half the measure of the arc that it intersects. So we divide the arc measure by 2. When we talk about semicircles, a semicircle is equal to 180 degrees. Let's take a look at that in a picture and talk about why, because this is going to come back to us in a theorem. The measure of a semicircle is 180 degrees because a semicircle is a circle that's been cut exactly in half. Remember that a circle measures 360 degrees. Divide that by 2, and I'm left with 180 degrees. So the semicircle, the arc, is equal to 180 degrees. Now, the inscribed quadrilateral opposite angles theorem tells us that if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. That means that the sum of the opposite angles is equal to 180 degrees. So, for instance, the measure of angle E plus the measure of angle C, because they're opposite one another, is equal to 180 degrees. We could say the same thing about the measures of angles D and B, and that their measures are added together equal 180 degrees. If we want to find the value of x, we need to write an equation that's going to help us do that. Again, because opposite angles are supplementary, we're going to say that the measures of the angles are equal to 1. Add the angles together. So we're going to say the measure of angle E plus the measure of angle C equals 180 degrees. Let's go ahead and fill those measures in with the expressions that we were given. 10x plus 9 plus 9x plus 19 equals 180. We could have just as easily added together the measures of angles D and B. Let's combine our like terms. 10x plus 9x is 19x. 9 plus 19 is 28 equals 180. If you're doing this with me, you should have a calculator at hand so you can make sure to check the math, know how to do this on your own. If I take 180 and subtract the 28, we're left with 19x is equal to, let me show that we subtracted 28, 152. Divide both sides by 19. I should have given us more room here on the in the table, we'll just bleed on through. X is equal to 8. And there we have it. X is equal to 8. Okay. Moving on to number 2. We're given that the measure of angle I, and let's highlight these with similar colors, is equal to 7x plus 5. The measure of angle H is equal to 6x plus 11, and the measure of angle G is equal to 10x minus 29. We want to find the measure of angle J. The measure of angle J. I don't have an expression for J, so I can't use it to start, but I do have expressions for I and G, two opposite angles, so I can set their measures added together equal to 180. The measure of angle I plus the measure of angle G is equal to 180 degrees. Those two angles are supplementary. Therefore, 7x plus 5 plus 10x minus 29 equals 180. 7x plus 10x is 17x. Remember, when we're on the same side, we combine. 5 plus negative 29, or 5 minus 29, is negative 24, equals 180. Let's add 24 to both sides. 17x is equal to 204. And then divide both sides by 17, and you're left with x is equal to 12. Now, we're going to use that information to solve for the measure of angle H. Because angle H and angle J are supplementary, and if I know the measure of angle H, then I can calculate the measure of angle J. So let's go ahead and do that. The measure of angle H is equal to 6x plus 11. We'll substitute x with the 12, the value that we just calculated, and we'll add 11. 6 times 12 is 72. 72 plus 11 is 83. So the measure of angle H is equal to 83 degrees. Again, recall that opposite angles are supplementary. Therefore, the measure of angle J plus the measure of angle H is equal to 83 degrees. I'm sorry, is equal to 180 degrees. Oops. And because the measure of angle H is equal to 83 degrees, we'll subtract that from 180 to calculate the measure of angle J. So the measure of angle J is equal to 97 degrees. And there we go. 180 minus 83. All right. New for us is the inscribed right triangle diameter theorem. This theorem states that if a triangle is inscribed in a circle such that one side of the triangle is a diameter, that's a key word here, of the circle, then the triangle is a right triangle. Right triangle meaning we formed a 90-degree angle. So what we can conclude then, and here's how we take a look at that. If I look at circle K here, I can see that ML is a diameter of circle K. ML is a diameter of circle K. Because ML is a diameter, that measure is 180 degrees. Remember, a semicircle is 180 degrees. That means arc ML, the measure of, is equal to 180 degrees. And recall that an inscribed angle measures half the measure of the arc that it intercepts. Notice that angle N intercepts arc ML because it shares the endpoints of the arc. So that tells us then that the measure of angle N equals half the measure of arc ML, or half of 180, which is 90 degrees. Again, when you have a triangle whose side includes a diameter of the circle, the angle opposite the diameter, let me make that arrow not so far, is a 90-degree angle, is a right angle. So let's go ahead and state that the measure of angle N is equal to 90 degrees. Let's put that into practice over here. Given circle O and the measure of angle R equal to 2x plus 10, let's go ahead and highlight that. Measure of angle R is equal to 2x plus 10. Calculate the value of x. Again, notice that triangle RPQ is inscribed in the circle, and that one side of that triangle is the diameter of circle O. Opposite that diameter is the right angle, the inscribed angle PRQ, that intercepts arc PQ. Because PQ is a semicircle with a measure of 180 degrees, angle R is equal to 90 degrees. So we can then say that the 2x plus 10 is equal to 90 degrees. Again, the measure of angle R is 90 degrees, so 2x plus 10 is equal to 90 degrees. Let's subtract 10 from both sides. We're left with 2x equals 80. Divide both sides by 2, and we can conclude then that x equals 40. Again, when a triangle includes the diameter of a circle, the triangle inscribed in a circle such that one side of the triangle is the diameter, the angle opposite that diameter is a right angle. And then finally, one last theorem, also dealing with right angles, is the tangent to a circle theorem. A line drawn tangent to a circle is perpendicular. Remember, perpendicular forms a right angle to a radius of the circle drawn to the point of tangency. The point of tangency. So where the radius and the tangent line meet, a right angle is produced. So let's take a look at our diagram here. Given that AD, so this segment here, is tangent to circle B, we want to determine the measure of angle DCA. DCA is this angle in here. Now again, remember that a tangent line and a radius form a right angle where they meet. So let's take a look here. AB is a radius. Let's write that in. AD is tangent, and therefore where they meet forms a right angle. Let's recall that a right angle measures 90 degrees. So if I want to calculate the measure of angle C, we're going to use our sum of the interior angles of a triangle theorem to calculate that measure. I know the two angles here, 90 and 50, and so I'm able to subtract those from 180 to come up with the value, the measure of angle C. So the measure of angle C equals 180 degrees. That's the measure of the interior, the sum of the interior angles of a triangle, minus the 90-degree angle, the right angle, minus the measure of angle D. 180 minus 90 is 90, and 90 minus 50 is equal to 40. The measure of angle C is equal to 40 degrees, DCA. And there we go. And then one more example. Given that AF, again, let's mark that segment here, is tangent. Let's mark it a tangent. to circle L, and the measure of angle AFL, that's this little guy in here, let's get rid of that, is equal to 20 degrees. Determine the measure of angle, let's see what it is, angle FAL, FAL, and so we do want to know the measure of that angle, and the measure of angle FLA. So that angle at the center, this central angle here. So because this circle has a center at L and LA forms a radius, we can conclude that the measure of angle FAL, angle A, is equal to 90 degrees. Let's get rid of, oops, I don't want to do that. Let's get rid of those so that we can make our right angle marker here. So again, the measure of angle the measure of angle FAL is equal to 90 degrees. Again, because it's the point where a tangent line and a radius meet on the circle. Okay. And then just as in problem number 5, the measure of angle FLA is equal to 180 minus that 90 degrees minus the 20 degrees at the top. 180 minus 90 is 90, and 90 minus 20 is 70. And therefore, the measure of angle FLA is equal to 70 degrees. And there we go.